In this lesson, we shall learn what the maturity structure of interest rates is. We shall study yield curves, understand what they are, and be introduced to the various types of yield curves. We'll also touch on forward rates, how to calculate them, and learn how to price a bond using forward rates. Let's begin. We've briefly touched on yield curve earlier. The maturity or term structure of interest rates is the relationship between interest rates or bond yields and different types of maturity. The yield curve plays a pivotal role in this study. Yield curves are constructed for yields of various types, and it's very important to understand exactly which yield is being shown. We shall study three types of yield curves using US Treasuries as the context: coupon bonds yield curves, spot rate yield curves, and par bond yield curves. We know that at any time there are many different issues of US Treasuries in the market. They have a whole array of times to maturity and different coupon rates. All of them are trading at different yields to maturity. If we plot their yields based on their time to maturity, we get a yield curve. A coupon bond yield curve shows the yield to maturities for coupon bonds at various maturities. Yields for bonds with maturities between data points are estimated by linear interpolation. Ideally, we want to isolate the variable to just the time to maturity of the bond. So when selecting the bonds, an analyst should make sure that the currency, credit risk, periodicity, liquidity, and coupon rates of the bonds are similar. However, the biggest constraint of using coupon bond yields is that the coupon rates can vary a lot. This means that coupon reinvestment risk for every bond is different, and that violates the basic assumption of all other factors being equal. This leads us to our second type, which is the spot rate yield curve, which is based on zero coupon bonds. This effectively solves the problem of different coupon rates, as zero coupon bonds do not pay coupons. So the ideal data set for a spot curve would be yields to maturity on a series of zero coupon government bonds for a full range of maturities. However, we know that US T-notes and T-bonds are mostly coupon-bearing bonds. We can, however, take reference from the yields of the stripped bonds. A stripped bond is a bond that has had its coupon payments and principal repayment stripped into two separate components and sold individually. The yields to maturity of the stripped bonds can be regarded as the yield of zero coupon bonds. They are calculated and plotted to produce the spot curve. The spot curve for US Treasuries is also known as the stripped curve or zero curve. Often, these government spot rates are interpreted as the risk-free rates. A par bond yield curve or par curve is not calculated from yields on actual bonds. Rather, it is constructed from the spot curve. The yields reflect the coupon rate that a hypothetical bond at each maturity would need to have to be priced at par. What does this mean? For example, if the par bond yield at 3 years is 2.39%, the appropriate coupon rate for a new risk-free issue which is priced at par would be 2.39%. How do we derive this 2.39% from the spot curve? Recall earlier in this topic we've learnt how to price a bond using spot rates. To price a bond, we discount all the future cash flows using spot rates. Just that in this case, our unknown is not the price, but the coupon rate, which is the payment. Remember that we want the bond to be priced at par, so this is the pricing equation for our hypothetical bond with 3 years maturity. We plug in all the appropriate spot rates from the spot curve and use them to solve for payment, which is 2.39. This is equivalent to a coupon rate of 2.39%. So here we've shown how to derive a point on the par curve using the spot curve. Any point on the par curve can be derived from the spot curve using this method. Besides being a useful tool to calculate par rates as we've just shown, a more common application of the spot rate is its relationship with forward rates. A forward rate is a borrowing or lending rate for a loan to be made at some future date. Besides the interest rate on the loan, one important component of a forward rate is the date of commencement of the loan, which is sometime in the future. The other component is the length or tenor of the loan. The notation to label a particular forward rate is to specify the time from today to the commencement of the loan, followed by the length of the loan. For example, a forward rate that is 2y 3y is read as 2-year into 3-year rate. It specifies the interest rate for a loan that commences in 2 years' time for a period of 3 years. A 3-year into 1 year specifies the interest rate for a 1-year loan that commences in 3 years' time, and so on. So what is the effect of spot rates on forward rates? Imagine you need to take a loan for 2 years. The most obvious option is to take a 2-year loan at the current spot rate of 3%. The other option is to take a 1-year loan at the 1-year spot rate of 2.5%, followed by another 1-year loan at the 1-year into 1 year forward rate. Let's say the 1-year into 1 year is 3.2%. Let's work out the total interest incurred over the 2 years for each of these two options. For option A, the total interest incurred is 6.09%. For option B, it comes in at a lower interest of 5.78%. So it's clear, given a choice, you would choose option B. But so will every other borrower, and not to mention arbitrageurs. You've studied the principle of arbitrage in the course on derivatives. You'll know that this forward rate will not hold. Arbitrage will only cease when both options have equivalent interest costs. If we solve for the forward rate, we find that a 1-year into 1 year rate of 3.5% will make the expected borrowing cost equal for both options. Arbitrage opportunity ceases, and investors should be indifferent between the two options. Here we've learnt the pricing relationship between forward rates and spot rates for 2 periods. This can be extended to 3 periods. In this case, we equate the 3-period spot rate to the power 3 on the left-hand side and add on the 2-year into 1 year rate on the right-hand side. Another way is to take a 2-year loan on the 2-year spot rate and follow that with a 2-year into 1 year forward. Or take a 1-year loan on the 1-year spot rate and follow that with a 1-year into 2 year forward. The relationship between any two spot prices and a forward price can be generalized into this formula. With this formula, an analyst can compute points on the forward curve based on the corresponding 2 points on the spot curve. Here's an exercise for you. Determine the 3-year into 1 year rate on the forward curve using the provided spot curve. Pause the video now and work out your answer. And we're back. The first step is to determine the A and B according to the forward rate we want. A is obviously 3, and we know B minus A has to be 1, so B has to be 4. Our formula to solve is therefore as such. Now, if you can't remember the formula in the exam, it may help to work this out pictorially. The loan we want to take is 3 years away, to be taken for 1 year. If we take a 3-year loan before that on the 3-year spot rate, this combination should equate to a 4-year loan on the 4-year spot rate. With this, you should be able to work out the formula. Plug in the figures for the spot rates and solve for 3y 1y. We get a forward rate of 4.61%. This rate is known as an implied forward rate, as it's not the actual market rate, but calculated from spot rates. Let's practice some more. An analyst quickly scribbled some rates that he needs for his work, but realized he forgot to take down the 5-year spot rate. Given the following rates that he has, is he able to derive the 5-year spot rate? Calculate it and see if he's able to. Pause the video now and work out your answer. And we're back. Are you able to identify the rates that can help us derive the 5-year spot rate? The 5-year spot rate is what we wish to find. On the other side of the equation, we have the 3-year spot rate that'll take care of the first 3 years, and the 3-year into 2 year forward rate for the next 2 years. Simply plug in the figures and we solve for S5. We get the answer 3.38%. So let's conclude with an application of forward rates. Given the following spot and forward rates derived from risk-free government bonds, calculate the appropriate price for a new 3-year risk-free issue, 4% coupon bond paid annually. As with what we've learned earlier, the principle is to discount all future cash flows and sum them up. Just that in this case, the discount rate is not fixed, but should correspond with the appropriate discount rate for each period. If you recall, we've learnt using spot rates to discount the cash flows. This should be the preferred approach, but in this case we don't have all the spot rates. We can, however, use the forward rates to derive the spot rates. The first payment can be discounted using the 1-year spot rate. For the second payment, we add on the 1Y rate. And for the final payment at maturity, we add on the 2Y rate. In order to calculate the price, we add up all the discounted cash flows, plug in the appropriate figures, and we get the answer of 102.406. For this example, please take note that the 1Y rate is the first rate here and not the subsequent one. Always remember that the forward rate is the rate going forward, while the spot rate is the rate till this point. And that concludes this lesson where we've learnt the different types of yield curves and what forward rates are and how to calculate them from spot rates. In our next lesson, we shall conclude this topic on fixed income valuation with a study on yield spreads. See you soon.